Let's see what is the next one trying to say. The next one says in the adjoining figure, quadrilateral ABCD is a square. Okay, fine. ABCD being a square. Triangle BCE is on one side of BC. Okay, this is what is BC, which is a side of triangle. At the same time, it's a side of square also. And triangle ACF on diagonal AC. Quadrilateral being a square, AC being a diagonal. At the same time, AC is a side of triangle also. Are similar to each other. So who are similar to each other exactly? It is these two triangles. The triangle which is formed by the diagonal and the side of a square. That is triangle BCE and triangle ACF are similar, given to us. Then show that area of triangle BCE is equals to half area of triangle ACF. We have been given the triangles are similar. Mind you, we have been given the triangles are similar. And we are supposed to find out area of dash is equals to half area of dash. Fair enough. So if the triangles are similar, what exactly we think about? Do we think about theorem on areas of similar triangle? We think about theorem on areas of similar triangle. For that we need ratio of side. Why? Theorem on areas of similar triangle says what? Area of dash upon area of dash is equals to dash square upon dash square. So here, before moving into the areas of similar triangle, the triangles are similar, so we can easily apply. Prior to that, what is the relation in a square? What is the relation between side and diagonal? In a square, what is the relation between side and diagonal? I hope many are aware. What is it? Diagonal is root 2 times side. Diagonal is root 2 times side. What I'm going to write down is, let me start my solution. Quadrilateral being a square, we'll write down this as quadrilateral ABCD is a square. Known to us, this is given to you, right? Can I say diagonal is root 2 times side? Therefore, AC is equals to root 2 times BC. Now the question arises that, sir, why have you written AC is root 2 times BC? You could have written instead of BC, AB, AD, DC also. Yeah, quite interesting. But why am I writing? Because AC forms or is a side of, one of the side of this triangle. BC is one of the side of this triangle. So that was the relation which I wanted. I think so by doing this particular step, by applying this particular knowledge, we are more or less done with our sum. What makes me say that? I'll just tell you the answer. So this is nothing but I'll just write down diagonal. Diagonal is root 2 times side. Diagonal is root 2 times side. Instead of giving this as equation number 1, if you want, you can give it AC is root 2 BC, or what I was thinking was you can say AC by BC is root 2 by 1. You can take this also. Now, what is the next step? Are the two triangles similar? Are the two triangles similar? So it is since triangle, now triangle, which two? AFACF similar to triangle BCE. This is also given to us. So can I apply very well area of triangle BCE upon area of triangle ACF? When I say BCE, is BC being one of the side? So I shall say BC square. When I say ACF, will I take AC as the side? AC square. Here, by what theorem, children? By theorem on areas of similar triangle. By theorem on areas of similar triangle. By theorem on areas of similar triangles. What next, children? Can I say area of triangle BCE upon area of triangle ACF as it is equals to, can I say this as BC square by AC square as BC by AC the whole square? I can very well do that. What next, sir? Sir, AC is nothing but root 2 times BC. So instead of writing AC, can I say root 2 times BC? So what is the next step? Left hand side is as it is, area of triangle BCE upon area of triangle ACF. This will be as it is. How about RHS? Instead of writing this as BC by AC, I'm substituting AC as root 2 times BC the whole square. From where did I get this? I got it from equation number 1. What next? Area of triangle BCE upon area of triangle ACF. How about BC square upon root 2 square 2 BC square? Can't I cancel BC square? Therefore, what is my answer? Therefore, my answer is area of triangle in fact BCE, area of triangle BCE, area of triangle BCE upon area of triangle ACF. What I shall do is I shall cross multiply ACF over there. I am left with 1 by 2. I am left with 1 by 2 is half area of triangle. This one going there becomes area of triangle ACF. I think so. That is what we wanted to prove. Check it out. That's what we wanted to prove. Area of triangle BCE is half area of triangle ACF. So what was there in this particular question, children? It was very simple sum. The moment the triangles are similar given to us, immediately we think for what? Theorem on areas of similar triangle. But the main thing was over here, the relation between the diagonal and the side for a square. In a square, diagonal is root 2 times side. The moment we use the relation, apply theorem on areas of similar triangle, we are done with the sum.